Hello dear student, how are you? I hope you are all will be fine. I'm also fine, thank you. Welcome to your channel. Let's start today topic. Today is the lecture number 7 of nucleophilic substitution reaction. In today's topic we will be study about the stereochemistry of the Sn2 reaction. How Sn2 reaction, Sn2 stereochemistry of Sn2 reaction, stereochemistry of Sn2 reaction. In today's lecture we will be study stereochemistry of Sn2 reaction. So let's start the topic. As we know that, as we have seen that Sn2 reaction acquired attack by a nucleophile on the back side of the electrophilic carbon like that. That is the electrophilic carbon, and this is alkyl halide. This is the halogen group attached, or you can say this is the leaving group attached with. So the coming nucleophile, that is OH or NH3, anything that is nucleophile, that can donate lone pair. These nucleophile can be attacked, as we have seen in previous reaction, that these nucleophile can be attacked on the back of the carbon, from the back of the carbon of the electrophilic carbon. The back side is, you can say that the opposite side of the leaving group. So means there is the lobe, there is two lobes of the orbital on which leaving group attached, leaving group bonded. This is the orbital, in which leaving groups are bonded. Yeah, this is the leaving groups, this is the orbital of leaving group that are bonded. So a carbon atom can have only 4 filled orbital, 4 filled, 1 2 3 4, only 4. Carbon has only 4 filled orbital, so their valency is 4. Bonding, so the leaving must leave as a nucleophile, the leaving must leave as nucleophile bond by to the carbon atom. As the nucleophile bond formation occur, the leaving group must be leave the electrophilic carbon, because carbon has only 4 valency. Carbon can make only 4 bond, so that's why one bond should be lost by the carbon, and that bond will be the bond that are bonded with the bonded between the electrophilic carbon and the leaving groups, or you can say the electrophilic carbon and halide ion. So this bond should be break up. But as we study in molecular orbital theory, that bond have two lobe, each bond have, that each orbital have two lobe, one is positive lobe, one is negative lobe. If two bonded are if the bond formation are formed between, if molecular bond can be formed, either the molecular bond will be bonding molecular orbital, or it will be anti-bonding molecular orbital. So if the overlap of both sides, both lobes are same, like that, that will be formed, that will be produce a bonding molecular orbital, which will give stability to the atom, but anti-bonding can be formed like that, that will be anti-bonding plus, when this is opposite in sign. So when this formation occur, that will be produce anti-bonding, and anti-bonding result instability in the reaction. So as you can see here, that here is a bonding molecular orbital present, that is this molecular orbital is the molecular orbital between carbon and halide ion are leaving group, as it is the molecular orbital. So molecular orbital, you can that is the bonding molecular orbital, means it gives stability to the atom. But from the back side, this lobe of this carbon, electrophilic carbon, will form the anti-bonding molecular orbital. These are the lobe that are opposite to the nucleophile, so that will produce anti-bonding, and that gives instability to the atom. So as the nucleophile attack on this carbon, on this lobe, it will give instability to the carbon. So that's why, to gain the stability, the carbon, the electrophilic carbon, should leave one of the bond, that should be break. So that's why the bond between carbon, electrophilic carbon, and halide ion are leaving group, it will be breakable. So that's why the nucleophile, the or the compound can be get stability by this process. I hope this point will be cleared. But what is backside? What is meant by backside attack? What is meant by backside attack? Backside. What is meant by backside attack? Backside attack means literally backside attack literally turns the tetrahedron of the carbon atom inside out, like that, like an umbrella that caught by the wind, like that. That is when you draw the atom in three dimension, it will be like that, and tetrahedron, it will be like that. This is one bond. Let's suppose these all are hydrogen. These all are bonded with hydrogen. This is another hydrogen, but this is the one orbital that are bonded with bromide. Let's suppose that is the leaving group, and one bond is that. When the nucleophile attack on this carbon, when any coming nucleophile, that is, let's suppose nucleophile, when that are attack on this orbital, that will give instability to the atom. So that's why the atom, to getting the stability, getting stability, the compound, the electrophilic carbon should be break one bond, um, has the four bond present before. So that's why the bond between electrophilic carbon and the leaving group, it will be breakable. So that's why the bond, the carbon and the bromine bond, that will be polarized, and electrophilic carbon, that will be partial positive charge, and the leaving group will be get partial negative charge due to high electronegativity as compared to carbon. So this bond will be break towards bromide ion, or you can also say that will be produce transition state. In transition state, both the leaving group as well as the nucleophile, both will be attached to the electrophilic carbon. So it will be like that one. But in this case, in the transition case, the the tetrahedron literally, it will be turned, it will be like that, it will produce like this shape, it will produce like this shape. This is, let's suppose, carbon, this is bromide, yeah, this is hydrogen, and this is hydrogen. So it will produce, first of all, these both hydrogen are in partially left side, but here it will become in between the nucleophile and bromide ion. So like that, this is in between, this is transition state. This bond, the bond, this is transition state. The bond between nucleophile and the electrophilic carbon, it will partially formed, while the bond between carbon and the leaving group, it will partially break down. So this structure is called transition structure. But it will produce, after that, the bond between nucleophile and carbon partial positive charge, or you can say that electrophile, it will be completely formed, while the bond between carbon and leaving group, it will be completely breaker. So this structure will be obtained. Nucleophile, this is nucleophile, this is carbon, yeah, this is hydrogen, this is another hydrogen. Now you can see, as you can see that here, like this is umbrella, this is umbrella, let's suppose this is umbrella. When there is high wind, it can be caught by the wind, so it will produce, when there is high wind, it will produce like that, that is called caught. So in like in umbrella that is caught by the wind, similarly these molecule, when they are passed on Sn2 reaction, they will be caught like in umbrella. Like before, these two bonded are on left side, when there is only bromide and a leaving group attached to the electrophilic carbon. But when as the nucleophile attack on the electrophilic carbon, or as the Sn2 reaction processed, the system, the molecules will be completely caught by like in umbrella, like by wind, that is caught by wind. So these two hydrogen atoms will be completely on the right side, as you can see here. That is called caught, or yeah, I hope that point will be cleared. And this system, the this mm, in the product, the nucleophile assumes a stereochemical position opposite to the position of the leaving group, that is originally occupied. It means that nucleophile will be opposite to, let's suppose bromide will be, before bromide attached on this position, it was on this attached on this position, but now nucleophile will be attacked on the position that are direct, that are opposite on the leaving group. So we will use the term to this system is called inversion of configuration. That will be called inversion of configuration. Inversion will be occur produced. I already explained you in previous lectures that how the stereochemistry, like in stereochemistry of alkane cycloalkane, I already used the inversion of configuration. You can also search from there. And so here inversion of configuration will occur. I hope this point will be clear. There here is inversion of carbon, inversion of configuration of the carbon atom produced. This is the stereochemistry of Sn2 reaction. While in some cases inversion of configuration is readily apparent, for example, when there is cis 1 bromo 3 methyl cyclopentane undergoes Sn2 reaction, Sn2 displacement by hydroxide, and inversion of configuration gives a trans system. It will give us trans system. So how? Let's see. This is the cis 1 bromo hydrogen bromide ion, and here is CH3H. And this here you can see that this is bromide ion and C3 ion that are on the same side. So this structure will be called cis. Means cis 1 bromo 3 methyl. Cis, that is 1 bromo 3 methyl. But here, when there is Sn2 reaction involved by the hydroxyl ion attack, when here is strong nucleophile used, strong base used, that is NaOH or KOH. So this strong base will be attacked on this carbon, this electrophilic carbon. This carbon is electrophilic because these are attached with, these are bonded with the most electronegative element that are bromine. So bromine will be withdrawing the electrons from the carbon and produce the deficiency of electron on this carbon. So that's why it will get partial positive charge, and the bromide ion will be get partial negative charge, and the bond will be polarized. And that's why the carbon will become electrophilic. So the nucleophile, that is OH, that can be attacked on this electrophilic carbon. When they are attacking, it produce transition state. Transition state will be like that. That will be transition state. That is OH that are not completely bonded. That will be shown by a dotted line, because partially the bond will be produced, the bond will be formed partially, and the bond between electrophilic carbon and hydrogen and bromine, it will be partially breaked. But here is H and here is CH3. So this is transition state established. This is transition state. This transition state, after that the bond between electrophilic carbon and hydroxyl ion, it will completely form by completely formation of bond. This bond, the another bond that are opposite to the bond between nucleophile, that will be breaker. So the bond between leaving group and electrophilic carbon, it will be breakdown. So that's why the final product will be produced. final product will be like that. That is OH, this is H, this is HCH3. So here you can see that, that is the OH and CH3 on the opposite to each side. Here is in case of third number, here in first number carbon OH on upper side, while in third carbon here is CH3 on the lower side. That's why that will be called transposition, because these are opposite in position. So it will become trans 1 hydrox, the trans 1 methyl cyclopentanol. You can say that trans 3 methyl, yeah, trans 3 methyl, because it is methyl are attached with 3 number carbon. Trans 3 methyl cyclopentanol, because OH is attached, so it will be called pentanol. It is become alcohol. So that's why the inversion of, that is the inversion of stereoisomers produce stereoisomer. The you can say that the inversion of specific reaction, it also produce stereoisomer, and these both are the stereoisomers to each other. Stereoisomers are those isomers in which stereochemistry are different. Means what is cis and one is cis and one is trans. I hope this point will be clear. These are about the lecture number 7, that is Stereochemistry of nucleophilic bimolecular nucleophilic substitution reaction. These are the stereochemistry of Sn2 reaction. I hope it will be clear. If you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put or drop in the description box. You can get from there. Also subscribe my channel. It makes me feel happy that my students are supporting me. Okay, thank you, very best of luck, my dear student.